Hi guys, good afternoon. So in the last session, we discussed the introduction part. Now today, let's continue. So we were seeing about VPN introduction, that what is VPN. So about VPN, what we can say, that VPN is a logical connection, okay, between two or more sites or devices, and it does not mean connection is secure. Now, why does it does not mean connection is secure? See, you can create a tunnel, but the tunnel is by default not secure. Okay, that we will see when we will configure GRE. That will configure a tunnel will be there, your traffic will be passing through the tunnel, but the connection, or sorry, the communication or the tunnel will not be secure. We'll be able to see what is there inside, what is traveling inside the tunnel. Okay, so this is not at all mandatory that your tunnel is going to be secure. So if we want to secure the tunnel, what we'll do, we'll use protocols. We'll use protocols like IPsec, SSL, TLS, these kind of protocols we are going to use. Okay. And we also saw in the last session that what does your VPN provides? VPN provides you three things, correct? Confidentiality, that is C, I, and E. C stands for confidentiality. I stands for integrity. And A stands for authentication. Okay. C, I, and A. So confidentiality is provided by encryption. Okay. Confidentiality is provided by what? Encryption. Then integrity is provided by hashing. And authentication, verification. So this will also be done with the help of encryption and hashing only, but we'll see how it is being done. Okay. So see here, the CIA. So to understand the CIA properly, to understand, this symmetric key, asymmetric key encryption. Okay. So if you see here, what do we have? Okay. See here, we have to see about what is symmetric key encryption, what is asymmetric key encryption. And then furthermore, we have to go with, these are the encryption algorithm. And finally, we have to go with the hash. So these all things, they fall under a term that is known as what? Cryptography. Okay. So let's understand about cryptography first. Then we will understand about symmetric, asymmetric, hashing, everything. Okay. So I have created one document for this. This is about cryptography. Okay. Now, what is cryptography? So cryptography is the conversion of your data into a scrambled code that is encrypted and sent across a private or public network. That means you are converting your human readable data into scrambled text or a ciphertext. Okay. And why we are using cryptography? Cryptography is used to protect confidential data. Now that can be anything. That is your email messages, your chat sessions, web transactions, personal data, corporate data, e-commerce applications, anything can be there. Okay. And what is the objective of your cryptography? So you can see here, confidentiality, integrity, authenticity, and non-repudiation. So non-repudiation is an optional one, but main is C, I, and E. These three are the important ones. Now, types of cryptography. So in cryptography, we talk about encryption. For confidentiality, we talk about encryption. And we know that encryption is of two types. One is symmetric encryption and second is asymmetric encryption. So if we are talking about your symmetric encryption, what is symmetric encryption? Symmetric encryption means your secret key, shared key, or your private key, whatever you are telling, that is going to use the same key for encryption as well as for decryption. Remember yesterday we saw the example about AES that we were using a Cisco key, right? So now in case of symmetric, there is a problem. When you are going with the symmetric encryption, there is a problem. What is the problem? First of all, if there are two sites, okay, let's take this as an example, that if we are having two sites, let's say this is site 1 and connected through the internet, and this is site 2. And these are connected via the internet. Consider this is site 1 and this is site 2. This is your internet. Okay. So if these two sites, they want to communicate securely, what they will do? They'll use a VPN. They'll create a tunnel here. Okay. They are going to create a tunnel. Okay, fine. They have created a tunnel. But to encrypt the data, they will require what? Encryption keys. And if they are using symmetric encryption, this time they are using what? Symmetric encryption. So if they are using symmetric encryption, what will happen? Let's say site 1 will decide a key. Cisco. This is the key. Okay, this is the encryption key. What it is? Encryption key. Okay. Now this encryption key, this has to be shared with the other site also. One copy of this has to be shared with the other site. And to share it, definitely you will be using some sort of media, right? So if you are sharing it through the internet only, there are good chances someone might sniff this, right? And if somebody will sniff this information, what will happen? They can also decrypt the data. If somebody will sniff this key, so because they have to use the same key for encryption and decryption. Okay. Now what? This is the kind of thing that you have to tell them the key somehow. Otherwise, without having the key, they will not be able to decrypt. Your site 2 people, they will not be able to decrypt. So if you want that, okay, our communication should be secure. Both sides, they should agree on one key. They should have the same key. And if you're sharing this key, because the same key is being used over and over again for encryption also, for decryption also, good chances this key might get compromised. This is the problem with your symmetric encryption. Okay. All right. So to overcome this, now symmetric encryption, it's not like it is not secure. It depends on the algorithm to algorithm. Okay, it depends on algorithm to algorithm. But again, if the key is compromised, can't do anything. And why there are chances that key might get compromised? There are chances of key getting compromised because you have to share the same key. This is clear. Now, in case of asymmetric, what happens? Asymmetric encryption. Okay. Asymmetric encryption uses, also known as what? Public key. Uses different encryption keys, which are called public and private keys for encryption as well as decryption, respectively. Okay. So what it simply means that you are using what? Okay, this diagram here you can clearly see that here the first thing we have, this one. This is for symmetric key. You can see the picture of the key here. Same key. Okay, so this guy is trying to, let's say, from the site 1. Okay. This is our site 1. And site 1 wants to send this data. That, dear John, this is my account number. and this is the account number. So this is plain text information. Okay. Now site one will do what? Will perform encryption and it will use a key here. This is the secret key, correct? And this data will be converted into what? Ciphertext, something that is unreadable. So while the data is traveling from your site one to site two, while the data is traveling from site one to site two, it will travel in this form. Your data will travel in this form. Okay, so if somebody is sniffing this, they will not understand it because this is a scrambled text. Okay, now what the site 2 will do? Site 2 will also require this key, correct? So see here, they are using the same key, and what they are doing? Decryption. So they are using the same secret key and they are getting the data. This is clear. Okay. And this is what? Your symmetric. Okay. This is for symmetric. Second case we have for asymmetric. In case of asymmetric, what will happen? This is the site one who wants to encrypt the data, right? So this is the plain text data again, same. They are using a public key. So in asymmetric, they will generate two keys, public and private. They will generate two keys, public and private. Private key, never shared. This is never shared. And public key, this is freely shared without any problem. Okay. So they will encrypt the data using the public key. And this is how the data will become. Now, if the site 2 wants to decrypt, they must have the proper private. So this is what your private key. So they must have this private key in order to successfully decrypt this information. Yesterday we saw in case of RSA algorithm that we generated two keys, public key and private key, correct? And using the public key, we encrypted the data. Using the private key, we decrypted the data. Okay, this is clear. But now you might have this thing that, okay, how this public key will be shared? What if somebody will capture this public key? This kind of things can be there in your mind, right? So let's understand this case also. Okay, similar concept we will understand using the other example for asymmetric key. Now see, this is your site 1. On this side we have site 2. And in between we have internet. And this is site 1. And this is internet. And this side we have site 2. Okay. Now, any data they want to share. But before that, to encrypt the data, they are using what? Which method? Asymmetric key they are using. So site 1 will do what? Site 1 will generate two keys. A pair of keys will be generated. Okay. They will generate one private key. Okay. So let me say this is site 1 private. This is the key they have generated. And another thing they will generate is what? Public key. Okay. So you can consider this is what? Site1 public key. Then same way, these people will also generate. Okay. This is site2 private key and site2 public key. Site2 public key. Here they have generated these two keys. Now they will exchange these keys. And like I said, these keys are what? Freely distributed. So that means the site1, they will share their public key with the site2. And site2, they will share their public key with the site1. Done the exchange. Now, let's say any data your site1 wants to send. Okay. So site1 will do what? Let's say they want to share a message. Hello. This is the message they want to share. So what they're going to do, they are going to encrypt this message. They are going to encrypt this message with which key? With the public key of site2. Okay. So they will encrypt this message with the public key of site2. So this data will get encrypted now. Now in the encrypted form, this data will travel from internet, right? And now what will happen? Site2, they are already having their correct private key. So what will happen? They will use this private key to decrypt the data. So this data will get decrypted. This is how it will happen. This is clear. Here, right now, I have just given this example. Public key will not go again. Just encrypted data will go. Okay. Same way, when this guy wants to respond, the site2 wants to respond. So let's say the site2 wants to say hi in response. So this thing they will encrypt using site1 public key. And when this information will come to site1, they already have their corresponding private key, right? So they will be able to decrypt this information. This is clear? Yes or no? So now, if there is a hacker in between, consider there is a hacker in between. Okay. There is a hacker in between. So let's consider we have a hacker here. And this is here. Hack. Now let's say site1 have encrypted some information, and hacker will also have his own public key and private key, right? So let's say hacker private key and on this site we have hacker public key. So now when this data is traveling from site1 through the internet, and if the hacker is sniffing it, now if the hacker will use his own private key, will he be able to decrypt? No. Why? This is not the correct key. And since this is not the correct key, hacker will not be able to decrypt. This is clear. Okay. Then another thing, this message will come to here and they have the corresponding private key. They will easily decrypt the information. This is clear. Okay. Now you might say that what if, okay, the initial case was that this key was available with site 1 and this key was available with site 2. Correct. So while they are sharing these keys, what if the hacker will sniff the key? Possible. If the hacker can sniff the data, hacker can also sniff the key. So that means one copy here and one copy will go here. And same thing from here also. One copy with the hacker, correct? And another copy here. So the hacker has sniffed which keys? Public key only. Now it doesn't matter even if the hacker has a public key, because here, if the data will be encrypted using the site2 public key, if hacker will sniff this information, how he will decrypt? If he will try to use this public key, same key cannot be used for encryption and decryption in case of asymmetric encryption. If he will use site1 public key, so this is a public key, not private key, and this is also not even corresponding to site2, will not work. If hacker will try his own key, not corresponding private key, cannot be decrypted. This is clear. Yes or no? Online people? Clear, right? Okay. Now, might be hacker was not able to decrypt this information. It's fine that hacker was not able to decrypt the information. But what if the hacker will change the information? That means, see, your packet is traveling in the form of binary. Eventually, it is what? Binary, traveling in the form of signal. What if the hacker will manipulate the signal? Possible? Hmm? This is where your integrity comes in picture. This is where your integrity comes in picture. See, on the sender side, on the initiator side, it will happen. Now let's remove these things. Now might be the hacker will modify the signal. That means correct information will not be delivered. So communication is secure. Hacker was not able to see the information, but hacker is able to manipulate it. Hacker is able to manipulate. Okay. So in those kind of scenarios, what we need something to check the integrity of information. That means your message has not been modified. This guarantee we need. Okay. So for this reason, what we will do, we will use what? Hashing algorithm. Okay. And before going to the hashing, let's talk about some of the algorithms for encryption. Okay. So if you are going with a symmetric encryption, okay. So in case of symmetric encryption, see, we have algorithms like DES, REDES, and AES. Okay. And asymmetric, we have like RSA, DSA, and DH. These are asymmetric encryption algorithms. So let's talk about these. What is a cipher? Basically, ciphers are what? These are the algorithms that are used to encrypt or decrypt the data. Okay. So we were having classical ciphers, which are not really working now. We require what? Modern ciphers. Now, these modern ciphers, they are based on key use like private key, which is symmetric, and public key, which is asymmetric. And they are also divided based on type of input data. So they are block cipher. That means they will take a fixed size of data and they will convert it into encrypted. Okay. And then we have stream cipher, which will encrypt the continuous stream of data. This is clear. What is substitution cipher? One of the very simple example of encryption, if I give you, okay. So understand this. The simplest encryption that we can do, and you can understand also easily. See here. Let's say I want to send a message to someone and I want to say, hello, how are you? This is the message I want to send. But I want that whenever I send this message, nobody should be able to understand it. Right? What is my requirement? Nobody should be able to understand it. Now, for this thing, what we can do? We can encrypt this information. And the simplest method in the traditional ciphers, if we use classical ciphers like substitution method. So what we can do, we can sift the characters. What we can do is we can sift the characters. So that means according to this, let's say my encryption key will be what? +3. Now, what does it mean? It means H. After H, go 3 characters forward. So what it will be? So I, J, and K. This will become K. Right? Then E. After E +3, F, G, and H. Then L. E or O? O, right? For O, right? Then next is A, R, Z, D. Then H. B. Z, A, and B. Right? R. Then this here is your data that is encrypted. Right? Now, now what you can do? You can send this. Now, one, you are sending this message. So if anybody will see this, they will easily understand. Right? And if you're sending this thing, then what will happen? Somebody will understand. They will look like, you're talking in some alien language. Right? So nobody will understand this. This is encryption. Simplest form of encryption. Nobody will understand anything. Then another way is what we can do. We can also have, that 2 sets we can have. Like maybe what I'll do is I'll not go like this, but I can say I want to encrypt the first character +3, and then I can say that second character is, let's say, +4. Okay. Now, what does it mean? Alternate. That means one character +3, one character +4, +3, +4, +3, +4. Now try. This will be K. Now this time it is 4. So this will be I. Then this will be O. So this is C here. This is +3, +4, +3, plus 4, then again plus 3, which is yk. So, understood? Then, see here, this was 3. Now this is will be 4. Then again 3, R, 4, A, okay, 3, D, 4, V, then 3, H, 4, C. This will be C. Then R, 4. Now C. This is another form of encryption. Now, if you say this, somebody will understand only this part, that somebody is talking about crime, nothing else, right? Or maybe this guy is crime, something like this. Okay. So this is how your encryption works. This is the simplest form of encryption. So what is our key here? This will become our encryption key. Now you have to tell the receiver side that, okay, this is the key. So what the receiver will do, receiver will perform reverse operation. So only sender and receiver will know about the key. Now, in between, if anybody will see this information, they will not understand anything, right? You might think like, okay, he was sleepy, so in sleep, he typed something like this. Happens, right? So this kind of thing. This is what your encryption is. Okay. These are different types of ciphers. So they are using different algorithms for generating the keys and for encrypting the information. Okay. So like DES algorithm. So DES algorithm, DES is designed to encipher and decipher block of data consisting of 64 bits. Okay. So here the key size is what? 64 bit. But out of 64 bits, 8 bits are used to check the error. 8 bits are used for error detection. That means real key size will be what? 56 bit only. Okay. And 56 bit is a very weak encryption. So this DES is known as a legacy algorithm. DES is what? A legacy algorithm. So DES is the kind of a block cipher, an algorithm that will take a fixed length string of plain text bits and transform it into a ciphertext bit of the same length. You know, kind of this thing you can understand. Like whatever the length we take, same length cipher will be there. Okay, so because it's a block cipher, so it will take a fixed amount of information and it will convert in the same length on. The data, encrypted data, will also be same. Okay. Now, see here. Due to the inherent weakness of DES, like I said, DES is a legacy cipher, very weak. So with today's technologies, some organizations, they will triple repeat the process. That means they will perform the DES operation 3 times. And this will become what? 3 DES. Kind of, you can say that the same operation you will repeat 3 times. That will become what? 3 times this particular algorithm. So if you are repeating the DES algorithm 3 times, it will become 3 DES. So what is the key size here? 56. So if you will multiply it with 3, 168. That will be the new key size. So you can see here. Okay, here it is not given in the 3 DES. Okay, so it uses either it will use 112 bit, that means 2 times of this, or 3 times of this. So 112 bits or 168 bit in the 3 DES. Is that clear? Always remember, higher the bits of encryption. Higher the bits of encryption, more secure is your information. Is that clear? Okay. Now, DES and 3 DES, these are legacy and not secure. So we are going with AES. AES stands for Advanced Encryption Standard. So this is also what? It's a symmetric key algorithm. Okay, used by the US government agencies to secure sensitive but unclassified material. And we are also using them in the VPN tunnels. And you know, this algorithm is also used in your Wi-Fi security. Which protocol? No. WPS is not protocol.
AES.
Yeah, AES, but which wireless security protocol uses AES? Which wireless security protocol uses AES? No idea. Your
Wi-Fi 3.
no, WPA2.
WPA2.
Yes.
Yes.
How many Wi-Fi security protocols are there? 2. CCNA. Hmm? How many Wi-Fi security protocols are there? 3. Huh? 1, 2, 3, 4, 5. Total 4 protocols are there. In the Wi-Fi security, we have total 4 protocols. So we have WEP. What is WEP? Hmm? No idea. Wired equivalent privacy, the first Wi-Fi security protocol, and very weak protocol. Hmm? And this was using RC4 algorithm for encryption. Okay. Then later on, WPA2 came up in the year, not WPA2, WPA1, or only WPA you can call it. This came up in the year 2003. Okay, because your WEP was very weak protocol. It was a very weak protocol. So it was easily crackable. Like, it takes hardly 30 seconds for a hacker to crack the WEP passwords. Okay. So WPA came up in the year 2003. Then your WPA it was just a temporary enhancement. It was just a temporary enhancement. Like here we were using 64-bit encryption. Then later on it was increased to 128-bit. And that encryption was increased again to 56 bits in the WPA. But still it wasn't secure. So later on in the year 2004, WPA2 came up. When it came up, 2004. So in WPA2, your AES algorithm was implemented. Okay. And even today in 2024 also, you will see most of the so many networks that are running over WPA2. But WPA2 is also vulnerable. Okay, it is vulnerable to your dictionary attacks and brute force attack. These attacks, it is vulnerable. So for home networks, this is not a problem, but for enterprises, this is a big problem. Okay. And then in the year 2018, WPA3 came up, which rectified all the problems related to these attacks. So right now, in the organizations, which is being used, WPA3. But the thing is, so many devices are there in the organization also, and in our home networks also, which are not supporting WPA3. And that is the reason still WPA2 is being used. Sorry? Dictionary attack. Dictionary attack is where, you have a list of passwords. You will have a list of password, and then you will try every single password to get an access. Okay. So for example, you have a Wi-Fi network at your home. Okay. Now, generally, what is the problem with the people that what kind of password they will keep? See, easily guessable. How? This thing, let me tell you, you will get an idea that really this thing happens. Okay. Most of the people, how their passwords will be. Passwords will be combination of either their name, okay, can be father name, mother name. This is in rare case. Most cases, partner name, right? then spatial dates, right? Date of births, yes. Mobile numbers, car numbers or vehicle number, car or bike numbers, right? These kind of things will be there in most cases. And another thing is, whatever the password you use in one place, same password you use everywhere. This is also one more habit, that if I have used one password on one website, same password I will use on all the websites and same email I will use. Correct? So what will happen if somewhere one of my password is compromised? All my accounts are already compromised. Correct? All my accounts are already compromised. Now, sometimes, people think they are being smart. People try to be smart. How? They will say that, okay, what I'll do is I'll use password as password. Now, if somebody will ask me password, I'll say password, right? Or some people will use password also, but some fancy password. This kind of thing they can use. Correct? So these are not really very secure passwords. Okay. These are the most common password. And sometimes people will think that, okay, I'll use keyboard. Something like this. Or some people will try to make a variation. This thing. Some people will try. These are very common patterns. We think we are being smart, but no, we are not smart. Okay. So if you see here, what the first thing that the hackers will do whenever they get a hash value or encrypted data, or whenever they want to get an access to a secure network, if they require some sort of password, the first thing they will do is Google. Okay. Most common passwords. Now see here. And you see here. So we think we are being smart, but no, we are not being smart. Now these are the most common password. 1, 2, 3, 4, 5, 6, 1 to 9, picture one, password. Okay. Then quality is there, Sneha is there. Okay. ABC 123 million to 00, I love you. Okay. Password one, then QQ double 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 one double two. These all are what? Very common password. See, this also I was telling you. First line of your keyboard, right? Second line. So these are very common passwords. Okay. And you will also see here, see the combination 1A, then you have, okay, this is what? One, and then the first line, second line, third line. In the keyboard, everything is there. So these are very common passwords. So hackers will do what? The first thing they will do is they are going to try these passwords on them. They are going to try these all passwords. And if some people, let's say, see here, okay, and these are only 200 passwords. What hackers will do is they will not use this list. Okay. See here, Wikipedia, giving 10,000 most common passwords. See, these are all the passwords. And there are very good chances that the password will be available in this. And hackers will not even use this. Okay. What hackers will use? Now see here. There is GitHub. There is the website I want to show you. Common passwords. Thank you, common node pass gather. on GitHub security. I think it has been removed. But website I have forgot. So basically, there is a word list with the name Rocky. Okay. I can find the website here. See here. So, this is the word list that like it's a text file. Normally, a text file is not very large file, but the ROCU, it is a file that is approximately 15 or 16 GB text file only. Okay, which contains millions of passwords. Okay, so hackers will directly run that. But before running that, yes, convert. Hmm? No. Don't think it's going to consume a lot of time because see, nowadays we are having what? We are having graphic cards. You all know about it, right? So graphic cards will increase the speed of checking the passwords, testing the passwords. Okay. So it's not going to consume a lot of time. If they have graphic cards, then definitely they can check millions of passwords within seconds. Okay. So that is why it said that your password should be like why the website says that your password should be at least 8 characters for this reason only. And your password should include spatial character, right? Number, name, capital, small, all these things. But what most people will do if they are using name, in the name N will be capitals. First letter will be capital. When it comes to using a spatial character, either at or hash. These are the two most common symbols. And last characters, definitely they will be these things. So this is the problem. And if you want to check whether your account has been compromised or not, okay, you can check. How? Just visit a website. This is the website. Here, just type in your email address and they will tell you whether your email was compromised in some data breach or not. Because what is happening, the problem with us is whenever we are visiting internet, any website, even if we don't want to use that website, but let's say you want to download some file, you have to create an account. Immediately, what we'll do, type in your email, type in password, same email, login. Okay. And I'm not just talking about any random websites. You can take example of very large and very well-known companies like Big Basket, okay, Swiggy, even their databases have been compromised. And see, what is the information we store in their databases? We give our location information. What is our location? We give our address, we give our name, email, phone number. We attach our credit card information, debit card information, and you can say UPI IDs and all. Everything is getting compromised. So here, all you need is this. You can go and type. So for example, I check my email. So you just have to type, and you see here, it has not been compromised. And if yours is compromised, you will get to it. Okay. This is clear. So one thing is stop using your personal emails everywhere. Whenever you want to use a website and you're using it for temporary purpose only, for some time only, always use temporary emails. Okay, so this is the best way. So these are the emails that you can dispose. If you are going to use the website for one time, two time only, that's after that. Whenever, let's say, for example, you forget the password, also no problem. Use create a different account. Correct. So here you will get your inbox and everything. So it's try to use temporary emails only if it is highly necessary, like banking sector is there and all. There you use your personal, no problem. But try to avoid. And if you want to use a secure email service, use Proton Mail rather than Gmail. Okay. Instead of using Gmail, start using Proton Mail. Right. See, this is Proton Mail is a service that is based in Switzerland. Right. You might have heard of Swiss accounts. Why? Very famous for black money. Very famous for Indian black money. Not coming back. Correct. So same kind of security they will provide to your email also. Okay. They will keep your conversations private in the Proton Mail, and they are an encrypted email service that is based in Switzerland. Gmail, Google is the largest data collector in the world. What we know about ourselves more than us, Google knows. Okay. So that is the scenario. This is clear. So we were talking about these things. So total 4 Wi-Fi security protocols are there: WEP, WPA, WPA2, and WPA3. Okay. So this dictionary attack. Now dictionary attack is where the hacker will have a list of passwords and hacker will try one by one. Brute force attack, hacker will try every single possible combination of password. That means hacker will try to use every single possible combination of numbers, characters, special character, capital, small, everything. So with brute force attack, there is always a guarantee that your password will be cracked. But there is a condition. It might take thousands of years also, but it will be cracked. So the hacker will die, password will get cracked. Okay. Clear? Now, this AES algorithm, this is highly secure algorithm also. So AES is a symmetric algorithm used by the US government agencies to secure sensitive but unclassified material. And AES is an iterated block cipher that works by repeating the same operation multiple times. Okay. So first of all, the algorithm is secure, and after that same operation, it is repeating automatically multiple times. Okay. So your AES has a 128-bit block size, and key size, see here, it varies from 128, 192, and 256. Okay. And if you see in our day-to-day life, whenever we are visiting websites, right? So this is also a type of VPN only. And here, if we check which algorithm is being used, AES, but key size is 256. Okay. So highly secure. Clear? RSA, you have used in your SSH, crypto key generate RSA, stands for reverse Shamir and Adreno. These are the people who developed this algorithm. So RSA is a public key crypto system for internet encryption and authentication. So RSA is widely being used. It uses modular arithmetic and elementary number theories to perform computation using two large prime numbers. So one of the example they have given here. Okay. That you will use what? Two large prime numbers. So here they have taken a small number example only. So P is what? Okay, P is your first prime number. Okay, and Q is your second prime number. These two prime numbers, then you will calculate the modulus. Okay, so kind of multiply them. This is multiplied. Now, this is your encryption keys. You have decided one of your encryption key, that is your public key and private key. So E and D for what? E for encryption, D for decryption. Okay, now what is happening here? This is your encryption key. This is your decryption key. So your public key is used for encryption. So this is what your key, and your private key is what? D. That means this is your private key, this is your public key. Now, if something has to be encrypted, so the formula is whatever the text you want to encrypt, power E. E for encryption key. That is your public key. That means, see here, it is telling basically that for encryption, what we are using? We are using public key. Here, what we are using is public key. Okay. And then modulus, whatever the modulus it is. Then after, for decryption. So whatever is the ciphertext, C means what? Ciphertext. After calculating, your encrypted data will be there, which will be your ciphertext. So that ciphertext, you are using the decryption key to decrypt it, and then you will get your your plain text. So for an example here, they have taken an example like you are encrypting what 123. So 123 power 17 modulus 3233. So this will be your value. Then what you will do? You will use your, this is your ciphertext. So you will use what? Your decryption key. So this is your decryption key. So 855 multiply this and modulus 3233, you will get your real text back. So you don't really have to understand this thing, but all you need to understand here is that they are using two large prime numbers for calculating the keys. Is it clear? Okay. All right. So mathematical, we don't have to understand about these algorithms because this is just an example here. Actual mathematics is even more complex. Okay. All right. Then Diffie-Hellman, this we will be using. We'll be using Diffie-Hellman. So Diffie-Hellman is also what? It's an asymmetric encryption algorithm. Here we have seen, right, the examples of asymmetric, your RSA, DSA, and Diffie-Hellman. Okay. So with RSA, we have key sizes like, 512, 768, and 1024 or larger. So we are even still in the RSA also, we are going with larger than 1024 only. Either 1024 or larger we are going. Okay. So like here again, you can check the example. If I say view certificate, you can see RSA algorithm being used. What is the key size here? 204 for higher security. Okay, and this is how the actual modulus looks like. Okay, this will be a very large number. So Diffie-Hellman, this is a cryptographic protocol that allows two parties to establish a shared key over an insecure channel. That means, see, we want to share the same key on both the sides. We want to have the same key on both the sides. So with the help of Diffie-Hellman, we are exchanging that key. Diffie-Hellman allows us to have the same key on both sides. And so that if somebody is capturing that key in between, let's say whatever these guys are sharing, if somebody will capture in between also, then also they will not get to know the correct key. They will not get to know the correct key. How does it work? We will understand it, how DH works. Okay. But for tomorrow. Okay. We will understand again with a simple example, we will understand. Otherwise, real mathematics, this kind of mathematics will be there, kind of modulus and all. But we will understand it in kind of a simpler manner. This is clear? Okay. So now it does not provide any authentication. So this is an encryption algorithm. Your Diffie-Hellman will not provide any authentication. And that's why it is vulnerable to many cryptographic attacks. But it is, again, only somebody who is really capable of, having a something called as crypto analysis. Crypto analysis is what? That if you have some encrypted data, then you analyze the data and you try to decrypt it. So this is not true with the larger key size. Okay, like in the DH, you can see we have different key sizes. Like DH group 1, 768-bit group, DH2, 1024, DH5, 1536, DH14, 2048, like. So 1, 2, and 5, we again try to avoid these because I said that higher the bits of encryption, okay, more secure your information is. So normally we will go with DH14, okay. But when it comes to the ASA, we'll have to go with the 5 because ASA will not support higher. Okay. So you can consider like either 5, 1 or 2, do not never use it, and 5, 14, then above you can use. Yeah. Okay. Then hashing. So hashing is for what? Integrity. Hashing is for what? Integrity. So how the integrity is tested? What will happen? Whatever your data is there will be passed through some sort of algorithm, and this will give us what? A hash value. So the hash value, this is also known as what? Masses digest. Okay. So hash functions, they are like functions, they calculate a unique fixed size bit string representation called a masses digest of any arbitrary block of information. So if any given bit of the function's input is changed, then every output bit has a 50% chance of changing. Yesterday we saw from capital S to small h I changed, and my entire hash value changed. Okay. So it is computationally infeasible to have two files with the same masses digest value. That means two things cannot have the two different informations cannot have the same hash value. That is not possible. And that is the reason that masses digest are also called one-way hash functions, because they cannot be reversed. You cannot reverse engineer a hash value. But how does your hashing actually works? So one simple example I'll give you for the hashing also. Consider for an example here. Public key, private key. Okay. I'll give one example with a number. So let's say the data that I want to encrypt is what? 1, 2, 3. This is my information. So always remember, on the sender side, first of all, encapsulation will happen. What is encapsulation? Adding extra information in front of the data. That means kind of adding headers. Okay. Then after, encryption will happen. And then what will happen? Hash will be calculated. Okay. Then what will happen? On the other side, on the receiving side, first of all, using the hash, it will be tested whether your information is intact or not. If the information is intact, then decryption will happen. And after the data is decrypted, the data will be decapsulated. Okay. This is how the steps will happen. Okay. So let's say this is the information. This information will be encrypted with the public key. So as of now, let's say there is no encryption right now. Okay. Only integrity we want to understand. So this is your data. And you are using some hashing algorithm. So what the algorithm is doing is, let's say whatever is your data. So I'm representing data with the D. Okay. And that data will be multiplied by 1, 2, 3, 4, 5. That will become what? Your checksum. The formula to calculate the checksum for that algorithm is what? Whatever is the data, multiply by 1, 2, 3, 4, 5. Correct? Now, here my data is what? 1, 2, 3. So that means my checksum will be what? Checksum will be 1, 2, 3 multiply by 1, 2, 3, 4, 5. Understood? So what will be the output? Let's check. 1, 2, 3 multiply by 1, 2, 3, 4, 5. This is the value. Okay, so let's copy this. Okay, so my original checksum is this is my checksum, right? Now this data will be shared with this checksum here. The other side also knows the same algorithm, right? So what they will do, they will take up this data and they will run the same algorithm. So that means multiplication will be same only. The multiplication will be same. So what will happen? If the multiplication is same, the output will be same. Two values will become same and they will say, okay, the data is intact. And if somebody will modify in between, okay. So from here, let's say, for example, while the data was traveling from site 1 to site 2, hacker sniffed this information and hacker modified it. Okay. Hacker modified the information. So what will happen? Data is changed. This information will be shared. Now site 2 will do what? Site 2 will perform the calculation. Site 2 will say 124 is the data and multiply by 1, 2, 3, 4, 5. This is the value. So for this side, the value is this. Now what? Same or different? Different. The data has been modified, right? And if the data is modified, in that case, drop the packet. The masses will be dropped. This is how integrity test will be done. Okay. Clear? Online people? Okay. So the first algorithm is what? MD5. Okay. When it comes to hashing, see here, for the hash functions, we go with the MD5, SHA-1, SHA-2. Okay. Then we have hatchman. Okay. So let's understand. MD5. The MD5 algorithm takes a masses of arbitrary length. Okay, so it will take a masses as the input and then output a 128-bit fingerprint. So this is what? 128-bit fingerprint or masses digest of the input. So MD5 is not collision resistant. Use of latest algorithms such as MD6, SHA-2 or SHA-3 is recommended. So MD5 is again a legacy, same like DES3DES. MD5 is also what? Your legacy. Okay. Sometimes what will happen with MD5, there is a problem that MD5 and SHA-1, they can generate same hash value for two different data, two different information. That's why we avoid using MD5 also, SHA-1 also. And that is the reason either MD6 or SHA-2 or SHA-3 is used. So MD6 will make uses a Markov tree-like structure to allow for immense parallel computation of hashes for very long inputs, and it is resistant to differential cryptanalysis attacks also. Okay, like I said, cryptanalysis will be what? That you're getting a ciphertext, you're analyzing it, and then you're trying to know the real information. Okay. So MD5 and MD6 are deployed for digital signature application and file integrity checking and storing passwords. So you can see, whenever you go and download something, for example, if you're going to Cisco Software Center. So most of the websites, whenever they are providing you with, any product, want to software manager, not license, we want to download. And also you can see here, kali.org. Okay, you have to log in. Okay, just randomly I'm selecting anything. So whenever Cisco will provide you with any of the product, you see here, Cisco is also providing you checksums. One is MD5 checksum and another one is what? SHA-512. Okay. And same way, Kali Linux. Okay. So here, this is the Kali. If you click on some, so why they are providing this? So that whatever the software you are downloading, you can verify that somebody has modified it or not. Sometimes what happens that we download some softwares from third-party websites. Okay. So whether those softwares are modified or not, because it is always recommended to download everything from official sources only. Why from official sources? Because you have already seen, I think, I have showed you guys that what can happen with a double click, correct? Explosion. So a double click can lead to all that stuff. So you should never download anything from the third party. Okay. And this is why Cisco and all the software vendors, they are always giving these checksums. But how do you check? If you have this software, how will you check? So you will use some sort of calculator, like, we have softwares like Hash My Files. Okay. This is one, Hash My Files. So you can download these kind of softwares. Like if I have, let me check. Yeah, I have it. This is the Hash My File software. So what I'll do, whatever the file I have downloaded, okay, just take an example of anything. I'll just put the file here and it will give me checksum. See here, MD5, SHA-1, SHA-256, CRC, SHA-512, SHA-384. So it will give me multiple different checksums. Now what? I can go and verify this here, that are both the values same or not. If both the values are same, that means my software is okay, no problem. And if both the values are not same, then somebody has modified the program, right? So this is how we can check. Clear? Okay. Online people, clear?
Yes, sir.
All right. So this is MD5 and then we have SHA. So this algorithm generates cryptographically secure one-way hash and it was published by the NIST as a US Federal Information Processing Standard. So now we are not using MD5, we are going with the SHA only. Okay. Although in the VPN tunnel, sometimes you might use, some people might use, but it is always recommended to go with SHA only. Okay. So we have in the SHA also, we have SHA-1, SHA-2, and SHA-3. Okay. So same thing you can see here also, we have SHA-1, SHA-2, SHA-3 is not mentioned here. Okay. So SHA-1 produces a 160-bit message digest from a message with a maximum length of 264 minus 1 bits, and it resembles the, and this is the reason that it sometimes what will happen, SHA-1 and MD5 will generate same hash value, even though the data is different. Okay. So we avoid using MD5 and SHA-1. Then either we go with the SHA-2 or SHA-3. So it is a family of two similar hash functions with different block size, namely SHA-256 and SHA-512. So you can see like right now here, when we are going to the Cisco, they are giving what? SHA-512. Okay. And this Kali Linux here, SHA-256. So this is which algorithm? SHA-2. Okay. Secure hashing algorithm 2. Then we have 3, which is even more advanced. Okay. So they are also having some binary operation like XOR. Okay. So SHA-3 uses sponge construction in which massive blocks are XORed into the initial bits of the state, which is then invertibly permitted. So see, like I gave one example here, correct? This is for checking the integrity. This is for checking what? Integrity. Now, this is easy, right? although this also cannot be decrypted easily. This checksum also cannot be reversed easily. Why? Because, for example, my actual checksum was this. Now this is the value. So nobody will ever come to know how this value came. Nobody will ever come to know how this value came. Why? Because this can be the multiplication of any possible thing. Multiple factors can be there. Correct? So, but there are also chances that, okay, if somebody will be so desperate to crack it, he might do what? He might find out all possible combinations of multiplications. Possible? So if he will find, there are good chances he will come to know about this also. Like if he'll start from like 1 multiply 1 5 will be the same value, then he will keep on dividing and he will get to know the value. So to avoid this, modern algorithms, what kind of thing they will do is, they will say that we will also include something called a secret key. In this also, we will use something called a secret key. Remember in the Linux, I explained salt, that in the data, in the password, first of all, some salt value will be added. Then after the algorithm will be run. So that even if the data is same, even if the password is same, still the hash values will be different. So here what will happen? Yes, Rakesh. Okay. So here that salt is what? Basically the secret key. Okay. So this guy will do what? This guy will calculate a secret key, and this secret key will be shared with this guy also. These two parties, site 1 and site 2, they will know about the secret keys. Okay. So let's say, for example, secret key they have decided is, let's say we will keep it as a 6789. This is the secret key. Now what? The formula for calculating checksum. Okay. See here. This time your data equals to D, your secret key equals to this, and the formula to calculate the checksum is what? D plus your secret key, that is 6789. Okay. And then multiply with the random value 1, 2, 3, 4, 5. This is how the algorithm will be calculated. Understood? Now, this is only the data. In the data, this extra thing will be added, then checksum will be calculated. So one benefit is your checksum size will be large. Your checksum size will become what? Large. So in this case, if I want to go with the 1, 2, 3 data, so what it will be? My calculator is, so first of all, 1, 2, 3 will be added to 6789. This value multiply by 1, 2, 3, 4, 5. Now this was my old. This was my old checksum, and this is my new checksum. Understood? So this time what will happen? That there are no chances he will ever come to know the correct data. Why? If he will find out every single possible combination of factor also, he will never come to know. Why? Because I had added something extra. So there is no chance that he will ever come to know about 1, 2, 3. This is how integrity check can be made more secure. And this is why Linux also uses this scheme. So here what is happening, that they are using one single value, right? So here if the data is same, checksum will be same. Linux does what? Every time a different value. Linux will run every time a different value. Is that clear? Okay. Online people, this thing is clear? Yes or no?
Yes, sir.
Okay. Public key infrastructure. This is also highly used. Okay. Whenever you are using, right, internet, so how your websites are authenticated, how, like how this encrypted connection is established. So this is using what? PKI, public key infrastructure. So PKI is a set of hardware, software, people, policies, procedure required to create, manage, distribute, use, store, and revoke digital certificates. So remember I said that, okay, you will have what? You will have the public keys already in your browser. You will already have your public keys in your browser. Okay, so you can here understand step-by-step process. So what are the components in a public key infrastructure? Certificate management system. Then we have your digital certificates that will be issued. Validation authority, which will store the certificates. Certificate authority, which will issue and verify digital certificates. End user, who will request, manage, or use the certificate. And registration authority, who will act as a verifier for the certificate authority. See here, this is a guy and he wants to do some shopping here. Okay, so this user will do what? He will apply for a certificate. So he will generate public key and private key. So public key, he will give it to the registration authority. This registration authority will do what? Will generate a certificate. Okay, so on behalf of this user, they will request certification authority to issue the certificate, and this guy will get a certificate. At the same time, the certificate will also be given to the validation authority. See here. If you see, I think it is getting confused, right? You guys are getting confused here. This is important for an understanding. See here. Verified by KO Security Kaspersky Lab, right? So that means there is somebody who is verifying. So this is the validation authority. Okay. So now whenever this guy will visit, so he will use a public key. He will use the certificate with the public key. And then this guy, this shop, whatever it is, they will verify it from there, that whether this guy is legitimate or not. If the guy is legitimate, then whatever the result they will give, then based on that, this guy will be getting access. So this is how, you know, the authentication will happen. This is how your authentication is going to happen. This is clear? All right. So certificates are also two types: signed certificate versus self-signed certificate. All you need to understand is signed certificate will be coming from a trustworthy certification authority. Self-signed means ourselves. We will generate, like in FTD, you might have seen that we generated the certificate for SSL decryption, right? So that was what? Self-signed certificate. Then SSL and TLS, these things we will discuss when we are talking about the SSL TLS protocol itself. So you can see SSL is also an application layer protocol developed by the Netscape for managing the security of messages transmission on the internet. Okay, so here right now, you know, whatever the message exchange we are having, that is encrypted with SSL or TLS. So it uses RSA, asymmetric public key encryption, to encrypt the data transferred over the SSL connection. And now TLS is being used. So TLS is a protocol to establish secure connection between a client and a server, and to ensure the privacy and integrity of information during the transmission. So it uses RSA algorithm 1024 or 2048. So right now itself we saw that 2048 they are using. Okay, and what is the current version of your TLS? It is TLS 1.3. Okay. So these are the two protocols: TLS handshake protocol and TLS record protocol. So handshake protocol, it allows the client and server to authenticate each other, select an encryption algorithm, and exchange symmetric key prior to the data exchange. Okay. So these things, they will come in picture, like when we will study about IPsec also. So you will get to know that, okay, in IPsec also we have security association. So there we use ISACAM. Okay. We use the protocol ISACAM to share all these things, that, okay, which encryption algorithm, okay, which hashing algorithm will be used, all these things. Then we have TLS record protocols. So it provides secured connection with an encryption method like this. So the encryption will be provided, or the secure connection will be provided with the help of TLS record protocol. Okay, so it is giving examples such as DES, but it will actually use AES, we just have seen, right? So this is how your cryptography works. Clear? Yes or no? Online people?
Yes, sir.
So this is about your cryptographic methods. Now the next thing we will be discussing is about your VPNs. That what are the types of VPN? So routing based and policy based VPNs. And then we will directly start with the IPsec. Okay. Next thing we have to start is what? About IPsec. So today you have a task that you have to check about IPsec. What is IPsec? What are the protocols under IPsec? Okay. And we will have two protocols. Okay, we have an IPE protocol. First of all, you have to know about all the protocols that is there under IPsec. But we also use IPE, Internet Key Exchange. So under IPE, you will have IPE version 1 and version 2, right? So you have to know about the phases. What are the phases in IPE version 1 and what are the phases in IPE version 2? This is your task. Okay. So tomorrow onwards, we will go with the IPsec, the message exchange, and we will start doing some practical sorts. Okay. Drive access today you guys will get. Okay.
Sir, drive access, sir.
Today you guys will get. Yeah. Okay. So all these things, first of all, we'll go with the policy-based VPNs only. See, there are two types of VPN, that is routing. These are the categories actually. We have two types, which is site-to-site and remote access. Okay. And two categories are there, which is route-based and policy-based. So in the route-based, what happens? Your routing table makes a decision that which traffic will pass through the VPN terminal. And in your policy-based VPN, your access control list will make a decision that which traffic will pass through the VPN tunnel. So first of all, we will go with the policy-based. Okay, that means first of all, we will go with the IPsec. We will complete IPE version 1. Then we'll go with GRE and then GRE over IPsec. All these things we will do. Clear? Okay. So tomorrow, come prepared with the IPsec. Okay, IPsec is also important as per your interview perspective. Okay, so prepare it well. Clear, guys, online people? See, cryptography is something that, that will eat your brain. Okay, like fully mess up your brain. But once you understand the basics about, your symmetric, asymmetric, your hashing, that is more than sufficient. Okay, like mathematical calculation, you don't need, but how symmetric works, how asymmetric works, and like I have given you some examples also. So if you can use those examples to explain, that will have a really good impact on the interview. Okay, like simple examples, if we can use to explain the things, then what the interviewer wants. Okay, real mathematical algorithms we don't require. Clear? Yes, Dinesh, you want to ask something? So drive access, everybody will be getting today. Anyone online who is attending just today only? First day today? Didn't join yesterday? No one? Okay, so everybody will be getting the access today. I am Dinesh. Okay, so for people who are attending just today only, let me share the form link again. Anyone who is attending just today, submit the form, and those who have already submitted the form yesterday, they don't need to submit again. Okay,